our next one, we got quite a few things going on. First off, we see the division. Let's split that into the natural log of the fourth root of PQ minus the natural log of t to the third m. Okay, now let's break each of these down separately. That fourth root is a 1/4 power, so I'm going to write that as 1/4 the natural log of PQ minus, now we have multiplication, so we're going to have the natural log of t to the third plus the natural log of m, and technically I need parentheses here because it follows the minus sign. Now we're going to be able to take this PQ, which is multiplied, turn it into addition and distribute the 1/4, giving us 1/4 the natural log of P plus 1/4 the natural log of Q minus, and this power of 3 can come out in front, 3 natural logs of T minus, don't forget to distribute the negative, minus the natural log of m. And that becomes our simplified expression in terms of each argument is simplified. I agree that the original problem is one single logarithm simplified in that sort of way, but we're being asked to break this baby down into sums and differences. Now we go in the opposite direction. We can bring each of these leading coefficients up front into exponents, writing this as log of c to the 15th minus log of d to the 4th, which I'm going to write as the fourth root of d, minus the log of the fourth root of k cubed. Now we've got a bunch of logs, all of them base 10, common logs. Subtraction turns to division, so we're going to have log of c to the 15th being divided by the fourth root of d, and we're also subtracting off that log, which means we're dividing it also by the fourth root of k cubed. We can rewrite this now as the log of numerator c to the 15th, and denominator we can write that as the fourth root of dk cubed, writing that as a single radical expression. In this next problem, we're supposed to simplify this somehow. We see addition, which is going to turn into multiplication. So we're going to have log of, we're going to have 9t cubed minus 5t multiplied by this t to the minus first, which really means we're going to be dividing by, whoops, not 6, but t. I meant to write a curled t there. Now notice the numerator will factor and cancel, and we can divide a t out of each, which will make this log of 9t squared minus 5. Now we cannot turn that subtraction problem into any division, and that's kind of a different property. That would be division inside the logarithm turning into subtraction. So this problem is pretty much done. Okay, they're giving us a few different logs, log base b of 2, log base b of 3, log base b of 5. We don't know what base it is, so we have to use the clues they're giving us. And they're asking us to approximate log base b of 12 based on these clues. Well, can't 12 be broken down into 2 times 2 times 3? I'd hope so. And now that multiplication can be switched into addition, so I can have log base b of 2 plus log base b of 2 plus log base b of 3. Now we're going to have 2 of those log base b of 2's, or we can write that as just 0.356, 0.356 plus 0.356 plus log base b of 3 up here is 0.565. 0.565. When you add those three together, this is going to equal 1.277, and that is the answer to this expression.